into the 6th lab program. Design Verilog program to implement different types of multiplexers like 2:1, 4:1 and 8:1. A multiplexer has a group of data inputs and a group of control inputs. The control inputs are used to select one of the data inputs and connect it to the output terminal. We have 2:1 mux, 2 data and 1 select lines. We have 4:1 mux that has 4 data and 2 select inputs. In 8:1 it has 8 data lines and 3 select lines. 2 to the power n is to 1. 2 to the power n data and n select lines. Note that all multiplexers will have a single output. Let us write a Verilog program for 2:1 mux, 4:1 mux and 8:1 mux. Now let us first look into the 2:1 mux. Module mux x comma d comma y. Input 0:0 s, input 1:0 d, output y. Reg y always at s or d, case s. 0 is to y, d of 0, 1 is to y, d of 1. End case, end module. Let us now look into the 4:1 mux. Module mux s comma d comma y. Input 1:0 of s, input 3:0 of d, output y. Reg y always at s or d, case s. 0 is to y, d of 0, 1 is to y, d of 1, 2 is to y, d of 2, 3 is to y, d of 3, end case, end module. Now let us look into the 8:1 mux. Module mux s comma d comma y. Input 2:0 s, input 7:0 d, output y. Reg y always at s or d, case s. 0 is to y, d of 0, 1 is to y, d of 1, 2 is to y, d of 2, 3 is to y, d of 3, 4 is to y, d of 4, 5 is to y, d of 5, 6 is to y, d of 6, 7 is to y, d of 7, end case, end module. Now let us look into the output of 2:1 mux. When you give a select line a input 1 and uh, data lines 0 and 1, then output will be 0. And 4:1 mux, when you give a 1 1 as input for 2 select lines and 1 1 0 0 for data lines, then output will be 1. In 8:1 mux, when you give select lines say 1 1 1 and data line is 0 1 1 0 1 and 0 1 0, then output y will be 0.